teach going live. We are going to have a lecture now on statistical approach in research. Statistical approach in research. Do not forget to give us a thumbs up, like the video, and kindly share to others so that they can join us. We are treating the topic today, statistical approach in research. Welcome once again to this lecture. Okay? We are going to deal with some aspects of statistics and how we apply them in research. That is what we are dealing with today. So you are welcome to this lecture once again, and then don't forget to like and share this video to others so that they can join us in this class. We are going to deal with some few topics in statistics as related to research. We are going to talk about few items in statistics that we apply in research. Now, when we conduct research, we deal with various data that might need to be analyzed. And when you have data, you cannot make your conclusion unless you subject the data into tests. The scientific method does not allow us to assume or make conclusion based on merely looking or perusing a set of data. Rather, we need to subject them to hypothesis tests. First of all, when you observe what is happening in the natural world, you formulate an hypothesis, which is actually a prediction, an informed prediction. And then you now subject this hypothesis into tests. So we want to know about some of the tests that we have and how we can even describe data gathered in such manner. Now, when we gather data, I want to quickly mention that data are usually gathered in samples using random sampling. Random sampling. You have population, and population is a large group that you are actually interested in obtaining information from, but you cannot actually go through the entire group to gather the information. So you select a random, portion out of this group called a sample. So the sample is the portion that you use to represent the entire population, while the population is the entire group itself. But the smaller portion that you select out of the group is called sample. And this is selected randomly. You don't base it on any particular criteria that let's do this, let's choose that. No, you do it randomly. So we call it randomized sampling. Randomized sampling. So once again, the title for discussion is Statistical Approach in Research. Statistical Approach in Research. Okay? Statistical approach in research. So we are talking about data. We need to gather data many times, and then we need to describe the data or analyze the data to make some inference. All right? So we talk about a population, which means entire group of interests. Entire group of interests. And then we talk about sample, which is a smaller portion out of the group. Out of the group. So, and then we use randomized sampling to get data from this sample. Randomized sampling. That is, we obtain the sample randomly. The sample is obtained randomly. So welcome to the lecture once again. Do not forget to give us a like to this video and share to others so that they can join us right now. So can you hear me? If you can hear me, just type yes on the screen. I want to see yes. Yes on the screen. Just type yes if you can hear me. All right. Type yes on the screen if you can hear me. Okay, so now we have two types of uh, statistical approach that we want to mention. One is descriptive statistics, and the other one is inferential statistics. These are the two approach that we want to mention. We want to talk about descriptive statistics and inferential statistics. Now, before we talk about that, let's look at data. Data can be quantitative or qualitative. Qualitative, as you might know, qualitative. If it's quantitative, then we talk about numbers in figures. Numbers, I mean, figures. Here we talk about data that doesn't have a numerical value, no numerical value, no numerical value. But here in quantitative, we have numerical value. We have numerical value. So we talk about quantitative data and qualitative data. For quantitative data, we can do randomized sampling. Sample, the data randomly and obtain information needed in form of numbers. Okay. Now, we can give an example of data, quantitative data and qualitative. For instance, quantitative data, we can talk about students' performance in an examination, what is score in an examination. We can talk about age of people. We can talk about age of people. We can talk about length, probably length of some structures or objects, or perhaps roads or buildings, length. So we have figures to be recorded. Figures to be recorded. Or you took measurements and then you have to record the measurements in certain units. So these are examples of quantitative data. Quantitative data. Now, if it is qualitative data, we don't have such numbers to be recorded. Talk about example like skin color. Skin color. Either you are black, or white, for instance. Then we can talk about people's color of the eyeball. Color of the eyeball. It can be blue, it can be green, it can be black, and so on. So these are qualitative data that don't have numerical value. They don't have numerical value. So data is grouped into two. Now, if you measure people's temperature, for instance, you record, the values 37, 36, 38, and so on. And these are quantitative data. Now, if you look at set of people and you record their gender, that is sex, you talk about male or female. So that is actually qualitative data. So we have various examples on qualitative and quantitative data. All right. Now, let's move on to describe data. Then we can apply, especially quantitative data, we can apply descriptive statistics. We can apply descriptive statistics. All right. So let's look at descriptive statistics. What do we mean by descriptive statistics? Descriptive statistics. Generally speaking, we use a measure of central tendency. A measure of central tendency in descriptive statistics. And then measure of central tendency. We talk about mean, we talk about median, we talk about mode. We can use this to describe a set of data, quantitative data. We can use this to describe how the data looks like. We can look at the spread. Okay. All right. So we can use it to describe how the data behaves. We can plot graph, on y and x axis to describe how the data behaves also. Now also, on the other hand, when we talk about inferential statistics, we can talk about other statistical approach or calculation, such as the variance. We can talk about standard deviation. We can talk about kurtosis and skewness. Kurtosis and skewness. So those are inferential statistics that we talk about. Inferential statistics. Okay, I made mention of variance, made mention of standard deviation. Standard deviation. I made mention of kurtosis and skewness. Made mention of skewness. These are basically aspects of inferential statistics that we can calculate to determine the conclusion, to reach a conclusion or to draw certain conclusion about a particular set of data. Now today we are going to look at some inferential statistics that we have available, and we are going to look at their building blocks. For instance, building blocks of inferential statistics. Now, to actually give an example on a measure of central tendency, mean, median, mode, we can use a simple set of data like I have here. I have 2, 4, 3, okay, 5, 3, 4, 4. This is about 7 items completing a set of data. I have 7 values. Now, the 7 or 4 of them now, we can decide to determine what is the mean. And like you know, mean is average. So in statistics, let's all say we want to determine the mean now. Mean for this set of data. In statistics, the formula for calculating mean, which is actually average, is mean x bar equals summation xi divided by n. Xi is each item of this data, each of them. This is the first position. You can call this one x1. So I represent the position now. x1, x2, x3, x4, x5, x6, x7. So you can calculate the mean for this set now. If you do that, you can have something like 2 plus 4 plus 3 plus 5 plus 3 plus 4 plus 4 divided by their number. Their number is 7. Now, this is just arithmetic mean. Arithmetic mean, basic arithmetic mean. If you do this now, you realize that the summation is simple and the answer is also simple. If you sum these numbers up now, you will get the total to be 25. And this is 25 divided by 7. If you do that calculation right, what will you get? 3.57. So I want you to confirm at your own hand that this calculation is correct. That this is 3.57. Okay? That is what you get. Now this is the mean, which is arithmetic mean of this set of data. Now if you want to look at it again, you can look at, okay, what is the mode? What is the median? The mode, when you look at it critically, you see that the mode, which is actually the most occurrence item, here is 4. Mode is 4. Because 4 appears 3 times, mode is 4. Now you can also look at median. Now to get the median, you need to arrange the data in ascending order, for example. Can I say arrange it in ascending order and look at which one comes in the middle. The one that comes in the middle, you can use that one, call it the median. Alright? Call it the median. So that is what we have. So if you arrange this, you realize that 4 will be in the middle. If you rearrange them, there will be 4 here, 4 here, there will be 2 here, 3 here, 3 here, then 4, 4, 4, 5. So the one that will come in the middle will be 4. So this is just a simple example of a measures of descriptive statistics that we have, mean, median, and mode. Now, this looks simple, but we need it. We always need it, especially when we want to determine some inferential statistics. So we need mean, for instance, as the primary operation that we carry out for the set of data before we go ahead to apply further statistical method to it. Now, that is a simple discussion on descriptive statistics. Now we want to move ahead and do more work Now that will take us to inferential statistics. Inferential statistics. So we want to look at inferential statistics. Inferential statistics help us to make inferential statements about a population. Okay? Inferential statistics. Okay. Let me just rub this part. Okay. Inferential statistics, we have the example of statistical operations. Statistical operations that are grouped together that are called inferential statistics. For example, this is not descriptive anyway. Let me change this to inferential statistics. Inferential statistics from the word inference. So inferential statistics help us to make inference or draw conclusions about a particular population. But the conclusion we are going to draw is not based on data collected from the entire population, but based on the sample extracted out of the population in a randomized manner. Alright, so the random sampling that will be carried out, and then we now carried out analysis on the sample, then we go ahead to make an inference of what happened. Like you know, scientific method does not allow you to make a conclusion about a particular data set without subjecting it to scientific approach, such as tests, testing hypotheses obtained from the data that we have in hand. All right. So when you infer or draw a conclusion from a limited information you have, then you have actually carried out a conclusion based on the randomized sample that you have for the entire population. So the conclusion will be, extended to the entire population, even though the data used is based on limited sample. For instance, you can have a population of 5,000, for example. You can do a randomized sampling and obtain, let's say, 500, 750, okay, to form the sample that you will test. And then, after testing the hypothesis, you make an inference. After testing the hypothesis based on inferential statistics. All right, we have different statistical tests that we use in inferential statistics. For example, we have the t-test. It's called student t-test. We have the f-test or Fisher test. We have the chi-square test. This is called chi-square. Okay. We have the z-test. We have the analysis of variance called ANOVA, analysis of variance. So these are various ways by which we can test hypotheses and making an inference out of that. They are building blocks of inferential statistics. All right. So for instance, if you want to carry out t-tests, f-tests, and ANOVA, you will need some form of small work to be carried out. For example, you need to carry out variance on such data sets. So when you carry out variance, then you go ahead and apply your test statistics, any one out of these that you have chosen. Now, before you decide the test statistic, you must have observed the data you have, the quantitative data, to know what test is actually applicable, what inferential test is applicable for the data that you have. So after that, then you subject the data to test so that I can make an inference. I believe you can still hear me very well. So please continue to give us a thumbs up and then tell me in the chat if you can hear me. I want to see yes on the screen. Just type yes on the screen if you can hear me. All right. So now we want to go ahead and demonstrate how to calculate variance for a particular sample. Variance. I want to look at how to calculate variance, which is a building block for many of these tests. All right. So for variance, we can still use this set of data that we have here. Now you can now go ahead and determine their variance, to learn how to actually perform variance. Okay, this is a formula for calculating mean, and for variance, variance is represented as s squared. Variance, s squared, equals summation of x I minus x bar squared divided by n minus 1. That is the formula here. That is formula for variance. Okay, so we determine variance by this formula. Okay. So I believe that you have absorbed the formula on the board. You have seen the formula and you try to understand what it stands for. Okay. So this is variance, summation xi minus x bar. X bar is the mean, arithmetic mean. N, number of the items in the data set. Alright. So we can demonstrate how to calculate variance using this formula with this data set that we have. Now if you interpret this formula, it means s squared x1 now minus x bar squared plus x2 minus x bar squared plus dots xn minus x bar squared, everything over n minus 1. If you interpret this summation, if you expand it, this is what it represents. So if you employ this in this data set, we can have something like this. Okay, initially we need to calculate the mean. Don't forget we calculated the mean before. The mean for this data set is actually 3.57. 3.57. That is the mean. Alright, so if you employ that mean for this data set, we can have the first one, 2 minus 3.57 squared plus 4 minus 3.57 squared plus 3 minus 3.57 squared plus, okay, 5 minus 3.57 squared plus 3 minus 3.57 squared plus 4 minus 3.57 squared plus, the last one is 4 minus 3.57 squared, and everything divided by n minus 1, that is a 7 minus 1, 7 minus 1. So to do this expansion, squaring the difference in the inside each bracket, squaring them, and divided by 7 minus 1, you come out with a variance of this value. The variance is 0.816. 0.816. So I'd like you to confirm that at your own hand. Subject this calculation into analysis on your calculator and get out and confirm the answer. I want you to confirm that this answer is correct. Alright, so that is the variance for these sets of data. That is the variance. Mean is 3.57 and variance is 0.816. Now, after calculating variance, you must also know something. Sometimes you need to determine the standard deviation between a set of data like this. Standard deviation is actually a square root of variance. Standard deviation is represented like this, is equal to square root of s squared. Okay, so if you take the square root of this, this can give you square root of 0.816. That is the standard deviation now, which is 0.904. 0.904. That's the answer. You can confirm that at your own end. That is the standard deviation. This is the variance, s squared. Okay, and this is the standard deviation. So variance and standard deviation are related. Standard deviation is the square root of variance. So that is how to determine variance of a particular set of data. That's how to determine the variance. Now, having done that, we can also do more than that. Sometimes the data that we have requires that we do more than that. For instance, we have only one data set here. We can have a combination of data sets, and then we are performing test of significance between the two sets, for example. In that case, we need to calculate variance for each one. And then possibly we also calculate pooled variance. We can also calculate pooled variance. So pooled variance is based on variance of each set. So in that instance, we have variance for two sets. Then use the variance for the two sets to calculate the pooled variance. We are going to demonstrate that soon. But right now, I want you to show your own answer on the screen by typing the answer to the variance on the board. If you have actually done that, we want to see your own answer. But if you have not done it, just write it down. You can do that later. Okay, you can do that later. All right, so we can go ahead now and do more work. We can use a small set of data to demonstrate how to determine pooled variance. A pooled variance is necessary in some tests. For example, when you are calculating t-tests, student t-tests, we need pooled variance. So we can demonstrate how to determine pooled variance here. How to calculate pooled variance for a particular data set. All right, pooled estimates variance is for when you have two sets of data and you want to determine pool together. You're pulling them together, pulling the variances together to determine a particular number, which is pooled estimate of variance. So we can demonstrate that. Let's use two sets of data. We use a shorter data to do that in order not to take much time. But mark you, whatever we do for a shorter length of data is the same that we will do for a longer set of data. Yes, the same operation. You will realize that these operations are not too difficult, and then they are simple arithmetics, but you must not forget any step. You must not make mistake at any particular step. You must carefully go by the calculation, carefully step by step. For instance, the variance we just finished, you realize that we need the mean to calculate the variance. So one must not make mistake calculating the mean and then getting a wrong answer and using the wrong answer in the variance calculation. It will make the calculation also to be wrong. So one has to be careful. Calculate your step carefully, each step after the other. Right now we want to talk about pooled estimate of variance. Pooled estimate of variance. Pooled estimates of pooled estimate variance. Pooled estimate variance. Now, pooled estimate variance is a simple formula based on the variance of two data sets. All right, and it's given thus: s squared equals n1 minus 1. That is, when you have two data sets, then you have n1, then you have n2. That is the number of the items in the first set and number of the items in the second set. Then we have S1 squared. S1 now is the variance of the first data set, alright? Now you go ahead and do the same operation for the second data set, plus N2 minus 1 into, that is multiplied by S2 squared, S2 squared, and divide everything by N1 plus N2 minus 2 plus N2 minus 2. Look at the formula. It looks kind of, but if you critically look at it, you will see that it's very simple to remember because it's based on the original variance formula. Now what happened is that in this formula, you need several statistical calculations to arrive at this final one. For instance, you need to determine the mean for the first data set. You need to determine the mean for the second data set. Having got that, you need to determine the variance for the first data set and the variance for the second data set. Now, I will try as much as possible to use this small board that we have to determine the pool estimate of variance for a particular data set I'm giving now. But I'm going to make it to be short for 4 items in each data set in order to make the work to be short. But mark you, whatever we do for 4 items, you can do it for 50 items. 20, 100. The same procedure goes. The same procedure goes. So let's say the data set 1, the 2 data set given, I want to consider are like this. Okay. Let us assume we have 2, 3, okay, 5, 4. Let's say we have 3, 2, 6, and then 7. So this is the first data set up here, and the second one. Okay. So we need to calculate the pooled estimate of variance using this data set. So we follow the procedure one after the other. The first step is to calculate the mean for each set. So if this is the first set, that's 1, and this is 2, then we calculate the mean x bar, x1 bar. That is for the first data set. 2 plus 3 plus 4, plus 5 plus 4 divided by 4. That's for the 4 sets. And then x2 bar equals 3 plus 2 plus 3 plus 7 divided by 4. Mark you, in some observations, some data obtained, the length of each may not be equal to each other. Right here, we have 4 here, 4 here. That doesn't mean that it always comes like that. This one may be 4, while this one is 8. It doesn't stop your calculation. You still go ahead with these steps. It is still work for it. Okay. So let's look at this. This is 14 over 4. 14 over 4. And this is 18 over 4. 18 over 4. So we simplify this. This gives us about 3.5, I think. And this gives us about this one is also 3. Okay. 14 over 4, that's 13 over 4. Okay, that's 7 over 2, 3.5. And here we have 4.5. 4.5. Now, this is x1 bar, and this is x2 bar. So now, we use the two of them in the formula for variance, s squared equals summation of x bar over n minus 1. Now this time we have 1 and 2. So for the first one will be s1 squared summation of xi minus x1 bar divided by n1 minus 1. Then we repeat for the second one using the same formula, s2 squared equals summation xi minus x2 bar over n2 minus 1. So we use the first for the first set of data and the second for the second set of data. That's what we have. So we're going to calculate variance for each one now so that we can substitute into the pooled estimate variance to get their pooled variance together. Alright, so let's follow along. Let's run from here. Let's note x1 bar. X1 bar equals 3.5. X2 bar equals 5. So I want to rub this mean so that we can use the space to calculate the variance. Now the variance for the first set of data S1 squared equals 2 minus 3.5 squared plus 3 minus 3.5 squared plus 5 minus 3.5 squared, and then plus 4 minus 3.5 squared. Everything divided by 4 minus 1. Are we following that? Everything divided by 4 minus 1. And the answer, I will soon get the answer for you. And then S2 squared is 3 minus 4.5 squared plus 2 minus 4.5 squared plus 6 minus 4.5 squared plus 7 minus 4.5 all squared divided by 4 minus 1. And the answer, so we need to determine the answer for the two of them. Now, after determining the answer for the two of them, then we are ready to calculate the pool estimate variance. The pool estimate variance. Quickly, I want to get the answer for the two variance out here. I have 2, 3, 5, 4, 2, 3, 5, 4. Then I have 3, 2, 6, 7. I have 3, 2, 6, 7. 3, 2, 6, 7. Okay. Three, 2, 6, and 7. Now the variance for the two, let me quickly do that. Okay, for the first one, now is for, okay, okay, 2.19. The first one is 2.19. The second one, quickly, I want to do the second one now. That is okay. The second one, 4.5. Huh? Okay, I'm coming. Okay, it's not 4.5. I'm sorry. Beg your pardon. Okay. Okay. 4.25. 4.25. All right, that's the variance. Okay, so having got the variance, okay, we can go ahead and determine the pool estimate variance. It's now easy to calculate that. We have got all the parameters needed. We have n1, we have n2, we have s1 squared, we have s2 squared. So everything is now simple to solve. All right. I want you to confirm from your own end that these two answers are correct. Confirm from your own head that those two answers are correct. I've not done it before. This is just hypothetical data sets that I just wrote on the board, and I want to carefully confirm that they are right before we proceed. Okay. Okay, the first one. Okay. Sorry. Let me do it once again. I'm sorry, I want to do it once again so that there won't be any error. That is for, okay. The first one is 1.25. That's a mistake here, 1.25. And the second one, let me do the second one also. That is for okay. Okay. The second one remains 4.25. All right. So we can now determine S2 squared and the S squared for a pool estimate of variance. That will be n1 minus 1, 4 minus 1 into S1 squared, 1.25, plus n2 minus 1, that is 4 minus 1, multiplied by the S2 squared. That is 4.25 divided by 4 plus 4 minus 2, 4 plus 4 minus 2. Okay. So if you do this one, you realize that this is 3 multiplied by 1.25 plus 3 multiplied by 4.25. And you divide everything by 8 minus 2, 6. So let me quickly do that one using a calculator. Okay. So I want you to confirm your own answer too. I have 3 multiplied by 1.25. Okay. Okay. And that gives us 3.75. 3.75, then 3 times 4.25. 3.75 plus 3 times 4.25. 12.75 divided by 4 plus 4 minus 2, that is 6. So if you finalize this, okay, so you get 2.83. So the final answer is 2.83. This is the pool estimate of variance. I hope you follow. The final answer is 2.83. You can confirm from your own end. I assume that there's no mistake here. Now that is the solution to that. That is this long formula here employed for these two data sets. Alright, so as it is, that's full estimate of variance. In the future, you'll be learning where do we need this full estimate of variance. Of course, variance too, you will learn where do we need variance. And we need variance when we want to carry out some inferential statistics. Some of those I've mentioned earlier. Okay, so be on the lookout for more information on the channel and in class. Okay. Alright, so you can give yourself some examples to test your knowledge on what we have done so far. Get some data sets, calculate the mean, calculate the variance. Then you can also calculate the pool estimates of variance. For right now, I want to move on to something else in this lecture, in this statistical approach to research. Statistical approach to research. Now, I made mention of inferential statistics and some various types of tests that we can carry out in inferential statistics on some data sets. Now, I want to mention how we apply them briefly. We apply chi-square tests when we want to look at dependability of one set of variable with another, whether one variable affects the other or not. And when you have more than one variable, like 3 or even 4, and then you can use chi-square. When you have something that is expected in a particular data set, but what is expected is not what you actually observed. You know, expected value and observed value. Then you can subject them to chi-square test. Chi-square test is very good at this particular instance. All right. So we want to make mention of where we can apply them briefly. Squared tests. Chi-square tests. All right. The chi-square test. So when you have something that you expect, you are expecting particular data expected, and then when you now obtain the data, what you have is not the same as what you expected, so you have observed. So you can subject these two into statistical analysis called chi-square. Chi-square. All right. So chi-square test is very good, and then it can be used for 2 sets of data, 3 sets, even 4 sets. It's very good at determining that. So you can now make an inference. Now, mark you, when we are talking about inference, when you carry out a particular inferential statistics, there are standard values developed in tables that you will use to cross-check what you have done so far. You use standard value obtained from tables to compare your own. Then you now make a conclusion based on your hypothesis. An hypothesis, you must have formulated a hypothesis, which we usually have at least one alternative hypothesis. It will always have one null hypothesis, and one alternative hypothesis at least, or more than one alternative hypothesis. Now, it is based on this that you draw some conclusion, on what you have extracted from your inferential statistics. You draw conclusion based on your calculated value and the tabulated value in the statistical tables. All right. So that is what you do in scientific method of research. You calculate based on your test statistics that you have decided to use, based on the data set that you have, and then compare to what we have as standard values on tables, whether it is greater or less. So what you calculate a p-value, and use it to check what you have on the table to determine whether your conclusion, your assumption, your hypothesis is right or wrong. Either null hypothesis is right or wrong, or alternative hypothesis is right or wrong. So that's about chi-square. Let me also mention t-test. T-test, also called student t-test. Student t-test. So the t-test is carried out on two sets of sample, two sets of data. You have two sets of data. You cannot work on more than two sets of data at the same time. So you have two sets of data and you want to determine whether one variable, that is one set, is having an influence on the second or not. So you can use t-test for that. You can use t-test for that. For example, let us say you have a standard measurement, and then a machine is taking the measurement, and you as an engineer or a researcher, you develop another machine to take measurements. And so you use standard, tool, the standard tool to take the measurement, while you use your own that you just develop also to take the same measurement simultaneously, and you obtain sets of data. You want to find out whether your own measurements, is actually accurate based on the standard measurement that you have, you obtain with the standard tool. So you can use a t-test to do a comparison whether there's any significant difference between those two data sets. So t-test is good for that. Two sets of data. Likewise, the f-test. F-test is also good for two sets of data. Although not often used. It's not often used again, the f-test, but it is actually one of the tests that you can also carry out as inferential statistics. It's good for two sets of data only. You cannot do more than that. All right. Then we have z-test also. Z-test is there. You can use it. You can also use z-test. We also have we have an ANOVA, analysis of variance. ANOVA is like you are comparing something like you calculate their variances in t-test. You want to determine their variability to one another. Now, what happened with ANOVA is that you have more than two sets of values. You can have three sets or more, three sets of values or data, sets of data or more with ANOVA. So ANOVA can help you to determine, compare several data sets, like 4, 5, from 3 and above. So we can compare more than 2. Now, t-test and f-test, you can compare only 2 sets at a time, whereas ANOVA can compare 3, 4, and even more. And in most of the cases, when you are using ANOVA, you might even have more than one alternative hypothesis. You can have more than one alternative hypothesis to look at the influence of one data set over another in the sets that you have in hand. So you can use ANOVA to do that. So that is how we apply this inferential statistics. Now, in the future, we'll be dealing with examples to demonstrate how we carry out these tests and make inferences on various sets of data. I'm going to be looking at how to determine, how to conclude about a particular set of data, whether a variable is having influence on another, or whether there's significant difference between two sets of data at hand. So that is what we'll be doing subsequently. All right. Well, for today, we have introduced various approach that we use in statistics, talking about descriptive statistics, talking about inferential statistics. And now we have looked at some basic blocks of inferential statistics, which involve calculating mean, calculating variance, calculating pool estimate variance. And these are some building blocks for calculation in certain inferential statistics. So I don't know whether anybody has a question. You might want to type a question in the chat box so that I can respond. All right. So if you have any question, you can type it on the chat box so that I might respond at this point before I continue. Okay? We have about 5 minutes more or so to end the class. So I want to mention some few things, but if you have any question now, you can type your question before I continue. Okay. Type your question before I continue. Let me give you like 1 minute to do that. If I see your question, then I respond before we move on with the lecture. All right. All right, you can type your numbers into the chat so that I can see your comments as your comments. All right, somebody is asking about what can you tell us about p-value? Okay, p-value. Now regarding p-value, it depends on the test statistics that you use, and each one has its own formula to calculate the test statistics. I have not mentioned the formula for calculating each of this. I only mentioned some few things that is basic building block for some of them. For example, we calculated mean and variance. Mean is applicable in t-test, variance is applicable. F-test, mean and variance applicable. Under Z-test too, I think standard deviation. Standard deviation is needed under Z-test. And then ANOVA, we need a mean, we need variance also. But each one has its own particular formula for determining the p-value. The p-value that we are looking for. The p-value is what you calculate that you are using as your point of determination or conclusion of the data that you use it to compare the table values. So in the future, we are going to look at the table values after we must have calculated the p-value for a particular inferential statistics, such as the chi-square. So a particular a particular test statistics has its own formula for calculating the p-value, and you use whatever you calculated to compare what you have in the table, the tabulated value, that gives you, insight into your research, whether your research has any significance or not. So that is about a p-value. So if I see any other question, I will also respond to it. Right now, okay. Somebody said the answers are wrong. Okay. Anyway, I did the calculation just now. The sets of values I put on the screen were just, hypothetical situation that I wrote right now. But I believe that for you to say the answers are wrong, you got the procedure, how to actually calculate it. Now, I was doing my own using Excel table there. I did not use calculator to determine the values. So you can actually go ahead and determine the values correctly, knowing the steps that we have taken to arrive at the answer. I also suspect that the answers might be wrong because I do not want to waste your time doing it carefully. So that is why. So if the answers are wrong, sorry about that, but you know the procedure to arrive at the correct answer. That is the most important thing. So, and of course, in a test or an exam, nobody will give you only 4 sets of data. You have more than that, like 12, 15. Then you run the same procedure through the set of data that you have. All right. So somebody, I thank you for observing that the answers are wrong. That means you have actually tried it at your own end. You have tried it at your own end. That's fine. So let others too try that. Try it at your own end so that we can know whether the answers are wrong or not. All right. So after this class, another time we are going to talk about more points under that statistical approach in research. We're going to discuss further. All right. Feature of Z-test. Okay, somebody is asking what are the features of Z-test. Z-test is also used to determine significance, whether there's a significance between, say, a set of data or a particular value, considering the standard deviation. Considering the standard deviation. So when we give examples in a subsequent class, online or in the physical class, you will learn more about Z-test also. You learn about all of them. This one also can compare set of value. That is Z-test. Compare set of value. So I just give you brief summary of each one of them today. Subsequently, you learn more what we use them for, and we actually calculate them together. We will calculate them together. You see what we need them for. what we use them for, where they are applicable. All right. So if there is any other question, let me respond to them quickly. Okay. Somebody say he's so confused. Who is confused? I actually responded to him. He asked about Z-tests. That's what are the features of Z-tests, because I didn't write anything about Z-tests, but I've explained some of the features of Z-tests. Okay. And these are the things that you can also learn more about. And you are going to actually learn more in class, in our lecture. So for now, let me give you about 30 seconds more if anybody still has a question to ask. I'll give you about 30 seconds more to see whether you still have any question to ask. If you have any question to ask, then I will respond to your question. If not, then we call it a day for now, because of a poor network and things like that. So we may have to stop now so that we can continue some other times, online or offline. All right. So for today, we learned a lot about a statistical approach in research, and I want you to pay attention to the statistics that we calculated, the statistic parameters such as the mean, variance, pool, estimate, variance. We will need them in our subsequent lectures. You must know those formulae. It's a must, because you can be tested based on them. You can be tested based on those formulae. So please pay attention to them and practice with them also. All right. So thanks for joining this class. I appreciate your coming, even though we expected more people than what we have. But those that came, we thank you for joining the class, and we expect you to come next time. Now, don't forget to share the video, give us thumbs up and share the video. Until another time, I say thanks for watching and have a nice day. Bye. Ending the class now.